Here at the Birmingham Assay Office, we have been protecting consumers for nearly 250 years, and as part of our Centre of Excellence, the Cert Gem Lab plays a vital role in providing consumers with assurance that the item they are purchasing has been independently verified. Over the years, the Birmingham Assay Office has invested heavily in our people and equipment within the Gem Lab to ensure that we can give a complete service to the trade. Cert Gemological Laboratory carries out testing on diamonds, both natural and lab-grown, gemstones and pearls. We have a varied customer base who use our services. These include valuers, retailers, private customers, stone dealers, trading standards, and also the police. So let's head off now to the Gem Lab, where you can see the process and the equipment used to provide gemological testing for the jewellery trade and consumers.
Hi, my name is Fanny Raponi and I'm one of the operational gemologists here at the Birmingham Assay Office Gem Lab. I'm in the jewellery industry since 2007 and my qualifications include the graduate gemologist from GIA and the FGA from the Gemological Association of Great Britain. So this machine is called Synth-Detect and it has been made by De Beers, and we've chosen it because it has the 99% accuracy in identifying natural diamond and is also very fast to use. So this machine uses a very strong shortwave ultraviolet light that excites the diamond, and we will look for different type of reactions that are fluorescence and phosphorescence. So fluorescence is when you excitate a diamond and you are looking for the immediate reaction. Phosphorescence is when you excitate the diamond, then you stop the light, and then you look the reaction after. To demonstrate the using of the machine, I've prepared some samples because it is easier to show. So the first one is a multi-stone diamond ring. Okay, so we need to focus here. And we are going to look at all the types of reaction, so both fluorescence and phosphorescence. Fluorescence is a nice blue. Then this is what we are really looking for to have a result, that is the short phosphorescence. And as you can see, we stop the light, and then we know that the diamond is natural. So in this case, this is a definitive result. And we can also look at smaller diamonds because you can focus and see these are still natural, so it's a definitive result. And now I will show you so this diamond, it's a known laboratory grown. It has a very strong fluorescence and is greenish. And then the short phosphorescence, instead of being blue, is turquoise blue. But even in this case, when you have such a strong turquoise phosphorescence, we still have to do advanced testing because we had some very rare diamond that has the same kind of phosphorescence and they turn to be natural. So it's very important that even when it could seem obvious, it's not. Rare means that the diamond can be either a very rare type 2A, can be also a type 1, because diamonds are very complex natural diamonds, so you can expect all types of fluorescence and phosphorescence. Then it can be also a laboratory grown diamond, or a simulants like synthetic moissanite, synthetic cubic zirconia. But the important thing is that when it's referred to have a definitive answer, you need to do advanced testing. So in this case, it will be photoluminescence. Now, when the diamond is big enough, we can use a different, another screening device, that is the diamond shore.
My name's Elizabeth Passy and I'm an operational gemologist here at the Birmingham Assay Office Gem Lab. My qualifications include an FGA and DGA from the Gemological Association of Great Britain and a Bachelor of Science degree in gemology. So the Diamond Sure is an initial screening device for any stone submitted as a diamond for diamond certification. It can be used on loose stones over 5 points or any diamond set jewellery piece, as long as the mount allows us to have the light pass through. Some type 1 natural diamonds will refer on this Interdetect because they show unusual characteristics, whereas the Diamond Sure can be used to pass natural type 1 diamonds because we're looking for the 415 nanometer found in most type 1 diamonds. So all diamonds that will pass as natural diamonds on the Diamond Sure are type 1 diamonds, meaning we can be conclusive that they are natural origin and haven't been susceptible to high pressure, high temperature treatment. All type 2 diamonds will flag as refer on the Diamond Sure. This is because the Diamond Sure checks for a content of nitrogen in a diamond, which type 1 diamonds will have, and type 2 diamonds have a lack of nitrogen. So natural type 2 diamonds are rare. Generally, laboratory grown diamonds are type 2, or natural type 2 diamonds can be high pressure, high temperature treated. The Diamond Sure will flag all type 2 diamonds, so it's an essential piece of equipment for our diamond testing in the laboratory. So this is an example of a diamond set jewellery piece that we would use on the Diamond Sure. So as long as the light can pass through the diamond, we should be able to get a result. So the diamond has passed as a natural diamond, which means it's a type 1 diamond that has not been high pressure, high temperature treated. The machine doesn't, however, check for clarity enhancement such as laser drilling and fracture filling. So this diamond has given a refer for further test result. So if this diamond wasn't to pass using the Interdetect, it would go for further advanced testing using photoluminescence to determine if it was natural or laboratory grown origin.
My name is Krishna Power. I'm the Senior Gemologist at the Birmingham Assay Office Gem Lab. I've been in the gem industry since 1995. I have a HND qualification in jewellery and silversmithing, FGA DJ from Gemological Association of Great Britain, and the Diamond Graduate from the GIA. The equipment that we use in here is called the Raman Microprobe, but the experiment that we actually use is photoluminescence. It's a part of the spectrum that we narrow down to identify whether there is natural diamond or laboratory grown diamonds. So when all of our other initial screening devices do not give us a definitive answer, this is the machine that we would next use to give us that positive answer, whether it is a natural diamond or a laboratory grown diamond. The reason why we don't use this piece of equipment straight away is because we have a simpler method of getting to the result quicker. And that would be with using the Diamond Sure or using the Interdetect. So now we'll operate the machine. So we have set up our sample. We'll be using a laser, so we'd have to use our protective glasses. We're using a laser which is 532 nanometers, and this will excite certain areas of the diamond and we will be able to get a result. So this is a spectra of a typical laboratory grown diamond. We see in this spectra, we see typical features of a CVD grown diamond. Now, diamond has a very high vibronics, and what that means is that it's constantly moving, the atoms are constantly moving. So we use liquid nitrogen to actually cool the diamond down, and what the liquid nitrogen can do is stabilize them while we perform the test. Now, typically, when we have a mounted item, it's quite difficult to use the liquid nitrogen, so sometimes it can be performed without using that. But generally, first and foremost, we will use liquid nitrogen to cool the detector down of the machine. When we test loose diamonds, we will use our stage here. It's called a cryostat. It is a vacuum sealed chamber, and that will pump in liquid nitrogen, cool the stone down, and then we can perform the test. The Raman Microprobe has a big range of spectral identification library, so we can use this to aid identification for gemstones as well.
Thank you for watching, and I do hope you found it informative and helpful. If you need any further information, please head to our website, which is theassayoffice.com.